you can all rent one of these things and go for a ride and enjoy some other part of the country. Securing the vehicles, this is the active floor restraint system. Very simple mechanism. Each of these hexagonal floor pegs have a pressure sensor. So no matter what type of car you have, how many wheels you have, or how big they are, you pull in, park sideways, cock the wheel, whatever, it will always feel where the car is and create a wall around the wheel so that somebody's not going to try and drive out in front of this thing while it's doing 200 miles an hour. That's the safety mechanism. This is the low occupancy vehicle. Notice the configuration is slightly different on the motors. This is like the family truckster version. The taxi of the future, there'll be thousands upon thousands of these things on the rail, all built by Ford, GM, or Chrysler, or whoever. And these will be the ones you can rent or own. You may make an investment as a family, buy one of these things, use it once a month, and when you're not using it, you just watch your bank account increase because people are paying you to use it. So it's a great investment opportunity. This is the truck-mounted version for the logistics companies. A case in point, there's a couple of automotive professionals in here that work for very large automotive companies, and they know what it means when a truck full of $100,000 worth of parts is stuck in Chicago, and it shuts down a factory in Detroit, and the factory starts losing $1 million an hour. So having something like this for logistics purposes is absolutely ideal, because not all the trucks will ever necessarily need to ride this, but they will have the opportunity to do so. This is the Grand Traveler. Notice it's very large. Case in point, the rail gauge itself is 12 feet. The rail gauge on our rail system is 3 times wider than a standard rail gauge. It's no wonder trains come off the track because you've got a giant multi-ton locomotive on a wheelbase that's from the tip of my hand to about right here, and it's 4 foot 8.5 inches. How do you expect a train to stay on the tracks when there's nothing holding it up? So we tripled the width of the rail gauge and have tubes as a rail and motors that wrap around the tubes, so the motors won't come off. So it's impossible to derail these things. And because each motor supports 12,000 pounds, with 6 motors like you see here, that vehicle can weigh 72,000 pounds. So there it is. This could be your private residence, could be your retirement vehicle, could be a corporate vehicle, could be owned by your favorite sports team. So you don't have airplanes crashing and killing an entire football team in one air disaster. You will never have that problem with this. One of the nice things about this platform is that we can actually use it for medical response. Statistically, I can almost guarantee that somebody in this room lost a loved one in a car accident. I have had friends and family greatly injured in car accidents. 109 people will die today on our highway system, and we can save half of them with this infrastructure. Having the Triage Traveler available, which brings a complete critical care surgical team to the scene of an accident, instead of trying to load a damaged person into an ambulance, get through traffic, and try and get to a hospital. Let's face it, if you're an hour away from a hospital, you're dead. Even with a broken leg, you can die. So having this thing there is incredibly important. But also, that same Grand Traveler thing we looked at a minute ago, the luxury transport, can become the rapid response mass casualty response vehicle that is missing in the United States today. Think of Katrina. Think about how the highways were jammed with people trying to get away from the floodwaters that were coming inevitably. And it will happen again. We don't know when, but it will happen again. Having something like this means that we're saving more and more lives, and we will build these things and operate them. Now, a little more on the fun side. My dad is a breeder of Arab horses, so that is an Egyptian Arab horse on the screen there. Because we do business all over the world, and even here in the U.S., the horse industry is a multi-billion dollar industry. So having a vehicle such as this, again, the same Grand Traveler platform, you can actually load on a dozen horses and go out to Montana and enjoy a day of riding and then come back to Michigan in complete safety. And again, these are horses you see here. It might be Harley Davidsons, it might be bicycles, dirt bikes, snowmobiles. It doesn't matter what you want to put on it, the vehicle doesn't care, you build it any way you want. This is how we install it. We've got some friends at Caterpillar. We're very excited to offer the opportunity to them to build 96 of these installation cranes for the U.S. market and over 200 for the global market. So we're creating enormous jobs just in that industry, just building these installation cranes. It's a very large device, mostly big metal box, very simple. But notice that there's 6 motors per side, so it has the maximum load capacity because it has to be able to reach behind it like pulling arrows out of a quiver and put another rail section in, another stanchion pull in, and we expect to be able to do 1 an hour. So every factory, we're planning 12 factories in the U.S., will have 8 installation cranes installing rail 24 hours a day. That's where the 96 installation cranes come from. And incidentally, our production numbers are minimum 200 sections of rail a day per factory. That's 2 miles of rail per day. We're planning 12 factories in the U.S., so that's 24 miles of rail per day out of these 12 factories. In 100 days, it's 2,400 miles. So we will be able to build the Eisenhower system, all 54,000 miles in relatively few years. I want to just point out in the center the wheelbase of a car, of a truck, of a train. Again, a train's narrow little wheelbase compared to our 12-foot gauge. The vehicles are very large. Most people don't really see that at first, but these things are huge. It's like a double-wide modular home, but it's mounted on a maglev rail system. It can do 200 miles an hour or better. This artwork was commissioned by the city of Ferndale. This is 9 Mile and Woodward. We've pretty much abandoned this particular proposal because the people on Woodward do not want to have an elevated rail system. But we have an at-grade system which will be embedded into the pavement. But this is a half scale. It's a 6-foot gauge, and we're actually looking all over the world. A lot of people in the Middle East like the idea of having a smaller one in their cities. This is the traffic model. Notice that you've got main lines. The arrows show direction. So the main lines run unobstructed because there's a side track. And the side tracks run unobstructed because there's a minor loop or a store and forward buffer. That means you can have 3 or 4 cars queued in the buffer, and if you need to get through, the other guys can come around behind you and you can leave the loop and everybody stays right there. This is the only transit system in the world that has a store and forward buffer mechanism built into it like we do. This is the Solar City Traveler. This is the at-grade maglev system that will be laid into our pavement systems. It's relatively inexpensive. It's basically vulcanized rubber with coils embedded in it that are environmentally protected, so snow, salt, snow trucks, whatever. And actually, the pounds per square inch for that 30,000 pound bus is actually less on the road than having 4 wheels. Because 4 wheels really only have maybe that much space of contact to the road. So if you got a 30,000 pound vehicle, divide that 4 ways, and all of that weight is on that little spot on the tire. Our system spreads the mass over a very large area. And the stripes you see in the road here are the vulcanized rubber mats. They're about 8 inches thick, 33 inches wide. We've got 2 of them, and it allows us to levitate down the road. And these things actually have a better control than an automobile, because we can start and stop them faster. Here's the cross section and how that works. If you got any questions about it, just ask. I think I got to move through a few of these slides. So what do we do best? We talked about transportation, talked about the electrical distribution capacity, the hydrogen production and distribution, which is all very important. But right now in America and elsewhere around the world, water is the biggest problem that we have. So what do we do best? We create pure water from virtually any water source, whether it's the ocean itself or sewer systems, the borrow pits along the highway that are polluted. It doesn't matter where the water comes from. We can run it through a series of processes that we power ourselves with our own solar power network. We can render any water supply down into hydrogen and oxygen, which completely isolates any of the contaminants. And when we burn that hydrogen, we get H2O, pure water. And whether it's a fuel cell or an internal combustion engine from Ford Motor Company or whoever builds it, we will be able to produce an enormous amount of water. And it turns out as a base number, about 30 gallons per mile per hour. So if we have 1,000 miles, that's 30,000 gallons an hour that we're pouring out of the system. And right now, if you go to the gas station and pay $2 for a bottle of water that big, you're paying like 12 bucks a gallon for water, just to drink. And we complain about, putting $3 a gallon of gasoline in our car. We're paying $12 a gallon for a bottle of water. So it's actually one of our revenue systems. This is the utility substation.